Hi, Josh. Can you hear me?
Yeah, can you hear me?
Yeah, I can hear you loud and clear. Perfect. I can see you also. Excellent. Thank you so much for taking the time. Much appreciated. Perfect. So let's see, maybe first, Nick, can you maybe just open your cam? Oh yeah, perfect. I can see you. Hi, Nick.
Hello.
Hi there. So we have all of the panelists here. So thank you again, all of you, for taking the time. And really, the day has been quite long already. So we'll take it slow and kind of have fun with this. So rather than going for like really a precise discussion about, oh, what is, for example, exactly curiosity, I'm more interested about what interests you. What do you think are the core challenges? And how would you motivate, for example, new students or just generally new people entering the field or starting with this topic? How would you motivate them and excite them? This is really something interesting and larger than just kind of the one next paper, but rather kind of a substantial field of study. Okay, so as I said, kind of the one possible elephant in the room could be to try to define precisely what curiosity is. But I actually really like what Sid said earlier, that it's actually great that curiosity could mean different things for different people, because it brings different people from a variety of different fields, awesome backgrounds together. And so let's start maybe with the first question. And by the way, just as kind of a formality for everyone who's attending, feel free to post any questions in the chat, and we'll pick it up from there, or maybe raise your hand. That's also absolutely okay. And we'll pick these questions and then post them to our panelists. So let's start with the first question. What interests you specifically in curiosity, and how would you motivate a new student, let's say, to enter this field? And since we just finished with Leila, I would say we'll give her a little bit of time to kind of take a little bit of a breather, and we'll transition first to Nick, if that's okay. Nick, we'll start with you and then just do a quick round.
Sure. So the question, Hani, is like, how do we motivate somebody to start working in this field?
Yeah, and like what interests you in particular? So from your own experience, how would you motivate someone?
So for me, so there's a guy at ONR by the name of Mark Steinberg, who I think very highly of, and he once said that true autonomy is achieved when every single assumption that you've made about the world and yourself is violated. And so, and I like that vision. It means that, like, you know, everything that you think you know about your model of the world ahead of time is going to have to get changed. And so curiosity is really like, how do you actually gather information that predicts the changes in the world, that predicts what you're going to have to do in the future. And I think that's really compelling, is that I think that, you know, one of the limitations of some of the current techniques of machine learning in particular, but also robotics for sure, is that we tend not to do well once we leave the support of the training data. And curiosity is really about, how do you do well once you leave the support of your training data, and getting people to think about that long-term autonomy, I think, is really compelling.
That's actually great. So that actually relates a little bit to what the vision community is going through, and maybe Costas here, that would be a nice segue to you. In the vision community and also in the language community, they have these big models that are trained on like millions of images, for example. I don't know, all of these different neural networks, and in language, it would be GPT and so on. So that seems to work, however, to just kind of scale the data input and get really powerful and competent models. So do we still need curiosity for those domains where you actually have access to large data sets? And maybe this, what Nick just mentioned, is not so much of a problem. Actually, you're still muted, Costas.
You're still muted, Costas.
Is it maybe something from our side that we have to do? No.
At some point, the host has to let everybody unmute or something, maybe.
Okay. Now I wasn't allowed.
Perfect.
I wasn't allowed to unmute.
Okay.
So yeah, that's a very good transition. So I was working on some moving pan-tilt heads starting like in 1994, I remember, where it was called active perception at that point. And it was more about solving tasks like in a more efficient way. So then I transitioned to active sensing, more for active like localization and mapping and active localization. But when I started reading about curiosity and more reading actually outside robotics and machine learning, this really caught my attention because it was really the curiosity, the main difference during exploration with a pan-tilt head or exploration with a mobile robot was really the active process during like learning something. And this, as Nick mentioned, you have the possibility to select samples. And you mentioned that we have millions of samples available, but for vision. So indeed, practically, for few problems, it might not be useful, but there are a lot of problems like in mapping, for example, mapping environments like houses and being able really to create priors about this by having visited only very few houses or seen an object. So if you have been shown a very crazy object, let's say a blue broccoli or something, an animal with 3 legs, then you're showed it only once and then you're able to really recognize it again. And there are many applications in defense and others where I think that this as an intellectual, I really don't know. I really cannot tell you if it is really will bring it's good to start a startup on this, but it is extremely interesting intellectually. And saying something about the intellectual interest about this, personally, I was interested in curiosity because I realized that I was becoming curious by being bored, and my parents never allowed me to play video games. We didn't even have TV at home, so there was very little like passive or semi-active entertainment. And that's one. And I tried later to somehow justify this. And the second is this book here, The Usefulness of Useless Knowledge, which is from the founder of the Institute for Advanced Studies in Princeton. It just came out as a book. It was just an article. And I think even the main I'm speaking too much. I'm going to stop here.
No, that was great. Actually, I definitely have to check out that book. And I like the story that you told about yourself and kind of that effectively kind of you had to entertain yourself. Like you can't just use a video game where everything is there for you, but rather kind of you have to seek out information and in order to avoid boredom. So that brings us maybe to Josh then. So Josh, I mean, I know from your background that you've actually been straddling computer science and cognitive science and kind of more generally. So what would you say is your interest in curiosity more coming from the cognitive science side or more from the computer science side?
Yeah, I mean, well, my interests are very much at the center of those. I guess I would say, you know, I mean, a lot of my perspective was reflected in the presentation that you know you see from Nick and all that. I think that you know, some of the joint work that we've been doing at MIT will reflect that. But let me just add almost a perspective of things that complement what this workshop is hearing from the MIT crowd. we show in some of these projects how a kind of model-based, goal-driven approach to curiosity, which I think is very human-like, can lead to better learning, right? Just to sum up, I think the general thesis that we've been exploring is that, we ask, like, I wonder if I could do that, or what if I could do that? And by making goals for yourself and then trying to solve those problems, you learn some things that you wouldn't otherwise learn, or learn in a more efficient way. But I think from the cognitive point of view, here are some outstanding challenges that we still don't have on the AI side. One is integrating that kind of goal-driven, model-based approach to curiosity with stronger models so that what we learn is more generalizable. So like right now we can do things like learn to be a really good block stacker by setting goals for ourselves of like making taller stacks of blocks, which is really cool. But kids are able to, when we think about like how they play and how their curiosity works, they learn things that can apply to tasks which they've never, or which go far beyond that. So like how could, say, for example, by learning to stack up blocks, or playing with, another thing that kids like to do is, playing with water, like pouring water from one cup to another in the bath or at the kitchen sink. How can you learn something generalizable to new tasks that you haven't even thought of before? And maybe that generalizes to new, that's like the dynamics models are much more generalizable than just dynamics of how these blocks interact in center of gravity. So we need ways of, I think, taking that approach towards much more general kinds of tasks and models which go beyond a particular set of objects and goals. The other thing, which is even more, I think, puzzling and challenging, and here I'm just mostly channeling my colleague Laura Schultz, who's a cognitive scientist at MIT, who I work with a lot and also talks with our MIT team here, is one of maybe the greatest puzzle about curiosity for humans is, why are we curious about so many things that seem like they don't matter? Right? Like, I mean, it could be trivia, but it could also be just, we could set goals for ourselves. I could wonder if I could do that, like climb this mountain. What am I going to get for climbing the mountain? Nothing. Maybe a good view, but that isn't enough to justify it, right? Or I wonder if I could, win this contest or become a great basketball player, or even just learn to shoot a basketball through a hoop at all, right? So we create these goals for ourselves, and then we try to solve them, and we wonder how this works, or how I could do this. So what's going on with that? Is that functional? Is there something about the human drive to be curious about both sort of knowledge and possible skills and plans we could make, well beyond the things that we have any reasonable basis for thinking we're going to be rewarded for in the future, that is part of a generalized learning system? Or it's also possible that somehow maybe that's just an epiphenomenon of the system somehow, like it's just our, like cats like to hunt mice, and even if they're well fed, they still like to hunt mice. Okay, maybe it's that. Or another possibility, and here I'm just sort of summarizing some of Laura's thinking on this, and I highly recommend everyone to read Laura Schultz's stuff on this. Another possibility is that there's something about that at the individual level isn't really rational, but at the collective level of like a culture, society, or a species, leads us collectively to explore in all sorts of directions and to generate new knowledge in ways that, again, no one of us can anticipate. And it's sort of a cognitive capacity that's selected for either biologically or culturally at a level well beyond the individual. Science is a good example of that. We talk about like just curiosity-driven research, and even if the particular work I do I don't have any application in mind, I might discover things which I really had no reason to think I would have discovered, but I discovered them, and then somebody else figures out a use to put them to. So I don't know. These are all questions that I think we ought to try to understand and put into AI systems.
These are great points, and I like the last point in particular. Actually, like a curious idea can also be infectious. If you say, "Oh, I wonder if we could do this," people can rally around that and say, "Oh, well, actually, that's great. Let's do that." Which happened obviously kind of many times in science and in mathematics and other fields where people rallied around kind of a dream or an idea. But there's also the opposite of that. And so, for example, and this maybe transitions a little bit to Layla also. In these books, children's books, Curious George, where you have this little monkey kind of jumping around and exploring his environment. If you actually look at the books, or kind of read the books and look at the examples, many times the protagonist, so Curious George, is actually being scolded for the exploration. So the humans in the environment would say, oh, why did you touch that? Now it's broken. Why did you try this? So it seems also like curious behavior can also elicit kind of a negative response. And it seems, Leila, maybe this is a question for you, that some of your work already showed showed that tendency where people may actually respond negatively, but or at least not really super positively about curious behavior.
Yeah, I think that's right. I mean, I feel like, we were pushing the limits pretty hard on what, how curious the robot should behave. But I think there may be, there's a value function that you're trying to fit to, and there's a cost function too. And at some point, I think there may be such a thing as too much curiosity, right? We say curiosity killed the cat, right? And I love that my cat is curious, but there are some things like the kitchen knives that I wish he wasn't so curious about, right? Like just stick to the cardboard boxes and that's fine. And I think I think there's a low level of curiosity that has a clear value. There's this like medium, and we need to figure out where that boundary is, right? Where things start to fall off and have negative consequences. Kids have this great openness to new experiences, and anyone who's ever run a robot demo ever in the public, it's always the kids who run up to your robot and want to like climb on top of it and poke its lidar, right? And the adults kind of like hang back because we've been sort of acculturated into being like, no, you should just stick with your own stuff, how things work, right? Like don't explore, don't be creative, right? It kind of gets beaten out of us, but it's kind of lovely that kids are just go for it, right? And I think to your question about like why study this, we've seen in the social sciences that there's this kind of bias in our data where we've studied mostly college students in Psych 1 courses, right, at top tier R1 universities. And it just so happens that college students and we, academics and industrial researchers and people engaged in science, we like peg the needle on this one personality dimension of need for cognition, right? Like we're kind of like Johnny Five, or like, I need more inputs, right? I need more things. I need things to keep me not bored, right? Like we explore because we want to learn more. And wouldn't it be cool if robots could do that too, right? And I think for students that can be kind of motivating also, right? Like I think one of the damning criticisms of AI that I love is from, Lucy Suchman, who's basically said, there's plans and there's situated actions. And if you're going to actually do anything useful, like you got to be able to do both well. And at that point in time, right, this is decades ago, we were pretty good at plans and we were terrible at situated actions, right? And lifelong learning. And I think curiosity is this cool motivator, right, for enabling robots to learn on the job. And also for getting people to be a little more empathetic with robots, so that, if a robot is confused about something and seems to want to understand it but can't yet, like maybe that could build some empathy in humans for those robots too. So yeah, there's good and bad, right? Curiosity is not uniformly positive, but I think we can find the sweet spot in between and get some good benefits out of it too.
Yeah, sounds great. There are definitely a lot of research to be done there and kind of along those dimensions. But maybe as a question to the entire panel, so anyone who has an idea about this is, why do you think is research on curiosity kind of flaring up right now? Why is it like super hot right now? Because it's happening everywhere. Like I see it in reinforcement learning. I see like obviously in vision and all of these fields, like all of your work on HRI, for example. And it's just like, I've seen, I don't know, maybe around 2007, some of the kind of in the new era, you could say, some of the first papers. Obviously, kind of in the 80s and 90s, there, and even before that, there were quite a number of other papers. But it seems to come, or like the pendulum seems to swing very hard in one direction, then kind of pendles back. So anyone an idea of why now? Like, why is this interesting now again? Maybe Josh or kind of anyone from the MIT team kind of who have been also focusing on this lately.
Well, I think there's a couple of things. One is that we as I think a community, at least in robotics, we tend to oscillate between what we think are the hard problems. And we go from perception to planning back to perception. And the period of time on that is, I think, an integral number of PhD theses. So it's somewhere between, it's either 6 or 12 or 18 years. And so I think it is the case that, both perception and planning are hard, and you tend to think that the other thing is the solution to the problem. And so we've maybe gone through a period of time where there's been an intense focus on perception, and I think the recognition is that the models that are used to actually act are not keeping pace in terms of our understanding of how to build them at a sufficient level of complexity. And so it's time to turn back to our attention to where do the planning models come from, and how do we build them? And I think curiosity is a natural part of that.
Yeah, I might just add to that, if that's okay. Oh, I see Costas raising his hand too, but is that okay?
Go ahead.
Yeah, just to kind of extend on the same theme, I would say there are two timeless themes in, I think, AI, and then there's two moments now. The two timeless themes are active learning, as people have said, like or active perception, like going back to the beginning of learning and vision. People have always realized, like, it's not just enough to take data that comes to you, but like having an active information seeking loop is a key part of intelligent perception and learning. There's also the theme of like building machines and AI and robots that learn like children, like going back to Alan Turing or Marvin Minsky or pretty much every founder of the field, John McCarthy and AI. This idea that like we should let our machines learn like children, and children are curious and they play, and so that's just always been an inspiration. And those things just cycle back whenever people are ready for it. And then now I think people are especially ready for it for two reasons. One is that, where robotics has been making progress a lot recently, as well as, related areas in reinforcement learning and robot learning, is things that look like stuff that kids can do, like stacking up blocks and, manipulating objects in a tabletop, or sort of moving around in a limited environment. I mean, there's lots of places where robotics is making progress, but that is one area where people have been making progress. So people in robotics, it feels like, oh yeah, it feels like a sweet spot that the field is ready to take on now. And then there's also a need, because I think people, there's been a lot of work recently in reinforcement learning and a lot of successes, but I think people are rightly recognizing that sort of simpler approaches to reinforcement learning are not enough. There isn't enough reward signal in the environment. It's not the right kind of reward signal. We really need some other source of intrinsic motivation to get us to the places we want to learn. And so I think, it's the combination of those themes that might be driving things right now.
So I have also one more, like a pedestrian, let's say, reason. It is the ability that perception became so good that we can really predict and hallucinate things. And without this hallucination, we cannot really have a surprise. So we really, otherwise, so we, whether you use a prediction error or prediction information gain or prediction variance, before we would be able to do that in a state space, like, let's say, which is XYZ, and now we can do it with all like objects and semantics and all of that.
Yeah, that's a great point. So even the power, the computational, more like the representational power of these deep networks allows us to make predictions, as you said, kind of in high dimensional spaces with images, language, and so on. And so based on that, calculate, for example, the incongruence between prediction and what the real world is. And that seems to be a driver in many of these frameworks for curiosity. Yeah, that's a great point. And so I think, yeah, part of it is also like this cross-fertilization between the fields, like, and so some new results in computer vision help then kind of drive deep reinforcement learning, and then some new maybe kind of intrinsic reward function from deep reinforcement learning kind of is being reused in computer vision and other kind of subfields of AI and machine learning. So that's actually very interesting to see this kind of cross-fertilization. Okay, so with that, maybe kind of another question from my side. And by the way, to the audience, kind of feel free again to ask any questions. I don't think there is anything in the chat. So I'll just continue from my side then. And this is maybe kind of tongue in cheek a little bit. I think all of us have made this experience that when you write a paper and call it curiosity, you will get into trouble with the reviewers. And in fact, in my case, even when I just announced, so even after the workshop was accepted and I just announced it on LinkedIn, there was some debate going on with why I call, or why we all call the workshop Curiosity or Towards Curious Robots, because that's a very anthropomorphized name and kind of bees. And I actually had like a very long discussion with a colleague of mine on LinkedIn about this, not exactly the right platform for this. So what do you think? What's the reason for this, that actually writing papers on curiosity can be tricky, in particular in terms of getting it accepted? And is that your own experience, or maybe you found a way around that?
I'm hoping it's temporary, right? Because there was a point in time when it was offensive for us to say that we'd make intelligent machines, because we would say like intelligence is an intrinsically human feature, right? Like you have no business saying that a machine can be intelligent now. And then learning was the next thing, right? I wonder if maybe it'll maybe just be a matter of time before curiosity becomes a socially acceptable thing for machines to try to do, right? Kind of like machine learning feels fine now, but I think 20 years ago that might have been scary. And as we've seen, right, curiosity and learning are not the same thing in people's minds, right, when we're talking about robots.
Yeah.
So maybe we just wait. I guess might be one answer.
I think that's a pretty good answer in this. I mean, we need some term to describe what we're talking about, which is, intrinsic motivation in order to gather data. And, we could all be deconstructionists and say that, words mean exactly what we choose them to mean. And, curiosity is a label we've chosen here, and it doesn't have any greater significance beyond that.
And so in the meantime, we get our papers rejected if we use the word curiosity, or how should we do? Like a young...
My advice to a young grad student or faculty colleague is to accept the fact that reviewers can sometimes be idiots and move on.
I think another place where I've seen this is in people who use the word causality. I like the word causality and I like the word curiosity. They're both really important, interesting words for thinking about human cognition. It also seems to be a recipe for getting papers rejected. And one strategy is if you use it, be really clear. Like people reject it because those words mean many different things to different people. And people say, that's not causality because you didn't do this or you didn't do that. And they might say, that's not curiosity because you didn't do this, or you're just calling it that, but it's really this. So if you just mark it and signpost, like we're calling this, but we recognize, like we're doing, like say why you're using that word, why it matters to you to use that word, and grant that like there's lots of other ways to use that word and you're not covering those, and just try to diffuse things that way, rather than just like if instead like the default thing is to say, we want to do curiosity. What is curiosity? It's this, maybe it's this, and here's our model that does it. Then anybody who disagrees with you one way or another, thinks you left out something important, or just thinks you're like using a fancy word for some old thing, you didn't. They have reason to disagree. But if you mark why you need this word as opposed to some old thing, and why you're not doing a lot of other things that are really legitimate targets, and make sure to cite all the people who are doing those other things, then you immunize yourself against that to some extent, to put it really bluntly.
I think that's very, very good. I completely agree.
Very practical.
And totally reasonable, because these are important and thick concepts, and we don't want any one paper to suggest an oversimplified view.
Perfect. No, absolutely. So that's why I was saying also it's a little bit tongue in cheek. And as Nick already said earlier, like sometimes some reviewers are always out of the norm, and you just have to deal with that. That's part of the game.
That is part of the game.
Yeah.
Okay. So, but then that brings us. So since it could actually mean, or it can mean different things to different people and different communities also. That also has its advantages, because it feels like with this one concept, we could actually tie many different things together. So, for example, we saw in the work by Kostas that we can use it for vision, and so maybe that same signal can actually be reused by Nick and his work for reasoning, and then we can also use that signal to actually create an intelligent agent. or kind of a curious agent in Leila's work, and then actually have feedback from humans on whether they really perceive that as curious or not. So basically have a curious learning system, and at the same time get feedback from humans to see whether the amount of curiosity that we are generating kind of in our simulations or using our equations actually also corresponds to what humans perceive as curiosity. So do you feel that curiosity can be used as some sort of glue between different things, or is it still siloed at the moment?
I found it to be a good glue between spaces. I mean, I think after, for example, just giving a talk on these projects at UPenn, for example, at the GRASP Lab, we ended up striking up a conversation with Dinesh and some other folks who are doing reinforcement learning, right? And it's interesting to see, they have all these headaches around like users are just not that good at giving reinforcement learning feedback, right? And we know that from the human robot interaction side, like users, you can tell them that all you can do is say good or bad, but they will try to get their hands on the robot and show it how to do the thing when they do it wrong, right? And so there, I think when we talk about curious robots, we end up stumbling into useful collaborations between the disciplines, right? And so now we've been scheming up ways to try to get the humans to behave better, but also how to get the robots to be able to take the inputs that people want to give them to help them perform better. And I think it's a fruitful way to get the disciplines together who otherwise wouldn't.
Excellent. Anyone else kind of an idea or opinion on this, kind of whether you still think that it's going to be kind of siloed kind of research on curiosity, it's going to continue in a kind of a siloed fashion, or whether there is interest, or generally whether you see that people will come together and try to kind of form larger systems by combining the pieces?
I think the answer to your question, Henny, is yes. I agree. In the sense that, so robotics is a complicated discipline in many respects. Like, you have to know and be able to do everything, and building these integrated systems is a substantial engineering challenge. And so, and there are good engineering resources to be reductionists and study things as pieces, and we do that. And there's also good reasons to bring them together to make more capable system, and we do that. And curiosity is part of all of that. So in some sense, questions of curiosity are orthogonal to whether or not you're currently a reductive scientist or an integrative engineer. And I don't know that curiosity makes it easier or harder. It's useful at every place.
Perfect. Yeah.
Yeah, I would like also to mention that it's really, we are collecting a lot of data also about non-humans, about other species.
Mm-hmm.
We have, for example, a smart aviary where we monitor 15 cowbirds for like 24/7. And obviously you really see that a lot of motions are really, you don't know why they're doing them. And probably most of them are motivated by some kind of socialization. But with having a lot more data about from biology at any level, it would be, I think, it is a very open question to study any behavior that might be intrinsically motivated and not extrinsically reward.
Yeah. So I think that's also really interesting to see then what we can draw as conclusions from our work, or maybe kind of pose new hypotheses for kind of cognitive science and kind of curiosity in humans and animals. But maybe to slowly come towards the end, it's been also a super long day, and Josh has already to go. So thanks so much, Josh. And so just to come to an end, so going forward, what do you feel? So maybe each one of you can just say, what do you feel is for you, again, the next big important challenge? Some of that obviously was already highlighted in your talks, but maybe that represents kind of what your team has been working on, or what the future work is. But I think here I'm asking more from your personal perspective. What do you feel is the most important or a really critical issue that we need to address next in order to study curiosity and implement curious agents and so on?
I think there is two things: things we are most curious and things we regard most critical, and and they don't overlap always. I'm actually most curious on unifying the active learning from the purely machine learning perspectives, like the theory with all the theory that is coming more from the exploration side and the most recent approaches. But I think the most critical is still really to have a to measure the sample, for example, sample efficiency in curiosity problems, because even in the ones that you have seen around, even in what we are doing with environments and also all the open AI and the cheetah. This does not apply to MIT, by the way. They don't have so much data, and I realize that because we don't have enough data to train. But MIT uses much fewer data than others. But in general, even in curiosity experiments, still people use really millions of data and millions of episodes. And this is something that it is a cognitive dissonance to the motivation for intrinsic motivation.
Yeah. No, that makes a lot of sense. And yeah, and like, especially kind of any reinforcement learning based research for curiosity uses millions of kind of training samples. And yeah, that at the moment that really causes this cognitive dissonance indeed. So Nick, how about you?
I guess so. I certainly agree with you know, all the things that Kostas laid out are super interesting and compelling. But I think for me, there's two more. Having spent sort of a lot of the last 3 years hanging out with Leslie and Tomas in particular has imbued me with the need for our models to generalize, that our models don't generalize well. And I think getting, and I completely agree with them, and getting that the ability for us to like not just learn from small amounts of data, but to generalize from the small amounts of data seems crucial. I don't know how to do it. And the other is the thing I mentioned this morning, which is connecting our representations, in particular relational and symbolic representations, to perception. Whether that is formally symbol grounding or whether it's symbol grounding adjacent, I don't know, but that seems really, really important.
Yeah, I actually really like kind of how you used graph neural networks in your work, because that seemed like a potential easy segue, not easy, of course, but like a potential segue then to incorporate these vision models, because ultimately it's still a neural network, but now you can model these these relationships in an explicit manner.
Well, I agree with you. And honestly, that insight came from Mike and Izzy and Karis. So that is really all due to them. But I agree with the point for sure.
Excellent. And so, Leila, kind of we finished.
Yeah.
What's your opinion?
Oh God, there's so much, right? So I mean, I think we just started scratching the surface with what we've done so far. And part of it is like people putting up with curious robots, but the bigger challenge, right, is how do we get good data for these robots? How do we get good training data out of humans? And how do we get the robots to ask better questions, right? And so it's not just why, right? It's not like a 2-year-old that just asks why about everything, right? It's figuring out how to enable that interaction between the person and the machine so that you can do more efficient learning. And that the human is motivated and able to give better data for training. So there's both the quantity, right? Ideally, we can decrease the quantity required to do the learning, but also the quality, right? Because if people are not motivated to train the robot in a good way, they may be motivated to train it in a bad way that will not enable it to perform better. And I think there's a lot of, in robotics, I know humans often feel like we're the noise in the system, and we are. But we can, kind of shape that noise in a way that I think could be more useful for learning algorithms. And so to me, like that's the next big juicy problem to work on, is how do we get better training data out of people, and not just experts, right, in that field. That would be powerful to get a larger population of people who can train these robots and get them motivated to pitch in.
Absolutely, that seems to be a fundamental problem in all of this. But maybe kind of to come to an end here, let me just say kind of, I was really kind of impressed and mesmerized by the animations that you showed. I'm a big fan of like Pixar and Disney in general.
Yeah.
It was really cool. And actually, in a way, you can think of research on how to express and how to generate motions that actually express curiosity at different degrees, because which comes back to the question of data. In your case, you had access to an expert that provided you with these expert labels, you could say, these motions that express this. But we as humans are actually pretty good at recognizing curiosity in animals and like in insects and so on. And yeah, it would be interesting to see kind of what's the relationship between kind of this intrinsic drive and motion and kind of how to express that.
Absolutely.
And to interpret it.
Yeah. And part of the active perception, right, is like looking around the object and seeing it from different angles. And you just happen to get expressive behavior out of that, which is cool. Anka Dragon at UC Berkeley has done a lot of great work on taking an algorithmic approach, right, to making robot motion more predictable and legible. Maybe now we do making it seem more curious, right, and exploratory. That'd be pretty neat.
Absolutely. That would be amazing and would generate some really cool animations in the end. So I'm all up for it. We should discuss that at some moment.
We should always have animators on our teams because they're just fun.
And so I think with that, I'd like to thank all the panelists. It was great talking to you. This was great. Leila, Nick, Kostas, great panel, really interesting discussions. And I think one thing that I learned today is really that it's good that curiosity can have these different manifestations and different interpretations. I think that can be enriching rather than limiting, because it also opens up these many different kind of sub-questions that result from that. For example, what we just discussed about the motions and how they relate to that. But at the same time, you can always tie everything back together to a concept, or at least kind of a phenomenon. Even if it's not a single concept, it could be kind of some sort of phenomenon. And maybe as a result of that, we can then tie all of these pieces together and still kind of create these systems, because ultimately as roboticists, in the end, we create systems and kind of put them out into the world, and so that people can interact with them and actually see the result. And so with that, I come to the end of this panel, but also of this workshop. I'd like to thank everyone who attended today. This was great. I really enjoyed it. I learned a lot from this. And I would just like to say that you're all welcome to send us any emails, any follow-up questions that you have, or maybe any recommendations for a follow-up workshop, for example. So we're thinking of, for example, organizing a similar workshop in the future, maybe next year or so. And so if you have any ideas on how to go about that, something that we should do differently, something that we could have done better, feel free to reach out to us. We'd really be interested in hearing from you what you think, maybe any new idea that you have. So you can just contact any one of the organizers. And yeah, we definitely are super interested in hearing from you, following up with you. And as I said, so maybe there's going to be another workshop next year. Let's see. Who knows? We'll have to discuss that. But definitely from my side, I would be super psyched. And so with that, we come to the end. I'd like to thank all the co-organizers again. Soshi Iba from Honda Research Institute. We have Chris Mavrogiannis, who is at University of Washington. We have Josh Tenenbaum, who's at MIT. And also, of course, David Ezel from Honda Research Institute. And so with that, I say thank you all so much, and bye-bye.
Thanks for bringing us together. This is great.
It was great.
Thank you.
So much.
Thank
Bye.
you.